Assalamu alaikum. How are you, my dear students? I hope you are good. Alhamdulillah. Are you? I hope I am audible. Can anybody message me whether I am audible or not? Yes. Hi. 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 Yes, mashallah. That's good. So today we are going to see circles, and if time permits, I am going to see Heron's formula. Okay, because Heron's formula is very small chapter, and it has only I think one concept, main concept, and after that two three sub concepts are there which we usually don't focus. So let us see Heron's formula and circles. See, circles, it is very, very important because the theorems are very, very important. Inform your friends that class has started. Okay. Any in any group, or if you have any group or in the same group, you can inform others that class has started. Okay. So in circles, the most important thing is theorems, because these theorems are not only helpful for your grade 9 examinations, but they are also helpful for grade 10. Okay, if you want to score marks in grade 10 circles, you have to have the knowledge of theorems of grade 9 theorem or grade 9 circles. Okay, so let us see what are, yeah, I can do it. So what is theorem number one? Theorem circles, right? What is theorem number one, my dear students? Can anybody tell me? Are you able to? Yeah. Theorem one. Beta beast, please don't waste your time. If you waste your time, I will remove this chat option. Okay. I'm not at all feeling well, and please, please don't waste time. If you are here to waste if you are here to waste time, please leave and enjoy with others and with other YouTube videos. Okay. Yeah. Equal chords subtends equal angles at the center. So equal chords subtends equal angles at the center. So the next one, yes, this is very important, and you have proof for this theorem also, right? So if it is theorem 10.1, according to old textbook, it is 10th chapter and first theorem. And in new textbook, is it 8th or 9th? I don't remember. Is it 8th chapter or 9th chapter, my dear students? In the new textbook. Okay, fine. So it will be 9.1. So equal chords subtends equal angles. See, wait. Okay, my dear friends, thank you. See, these theorems, why they are important? Whenever you see a problem, check what is given over there. Okay, based on that, you have to use the theorems. Okay, now let us see what is theorem 10.2. 10.2 is nothing but the converse of it. So let us see only the theorems which are exact theorems. Okay, let us not go to converse because the same thing, right? So what is theorem 10.3? Very important theorem, theorem 10.3. Okay, third theorem of circles. What is the third theorem of circles? Can anybody tell me? It is very simple. See, I draw the pictures also. So equal chords. Let us say these two are equal chords, and you have a center. So the angles subtended by these two chords are equal. So this is important for proof. There are two theorems which are important for proof. The first one, and I think seventh one. Okay. So these two theorems can be asked to prove, because for you people this year we have only two theorems to prove. The other all theorems you have to learn. Okay. Yes. And what is the third theorem? The third theorem, if you don't remember the statement, at least remember it. So let us have a circle and we have a chord. Okay. If you draw a perpendicular from the center onto the chord, That means you have drawn a perpendicular line. So if you have drawn a perpendicular line, let me write A, B, and this is the point. Okay. So what is it? If OP is perpendicular to AB. So that means if a line is drawn perpendicular onto the chord, then it bisects the chord. Very good. So then bisects the chord means what? Then AP is equal to DP. You remember this. Understood, my dear students? Please remember. Whenever you draw a perpendicular from the center to the chord, it bisects the chord. You remember this concept, this will be used in your problems. So if you remember this theorem, you can solve so many problems. So can anybody tell me what is the perpendicular drawn from a line to any point? What is it called as? What is the perpendicular line drawn from a line to a point called as? Very good, Hazlan. Very good. So whenever we draw perpendiculars, two things for two things we draw. First one is altitude, to find the height. To find the height between two things. Okay, base and vertex, we draw a triangle to find the height of the triangle. Okay, good. And the second perpendicular is drawn to find the distance. Okay, the shortest distance. So that means OP is also the distance between the center and the chord. Okay, whenever we draw a perpendicular line, it bisects. So what is theorem 5? Theorem 4 is what? Theorem 4 is converse of this. So what is theorem number 5, my dear students? Theorem number 5, what is it? There is one and only one circle which passes through the center, which passes through the point. Okay. So theorem number 3, okay, Sohan. Theorem number 3 is if you draw any perpendicular line from the center onto the chord. Okay. For example, I have drawn a chord. Okay. Now, if you draw any perpendicular, so then it bisects. That means these two parts are equal. It is not only like this. If let us say that there is a very big chord, and if you draw a perpendicular, then these two parts will be equal. Understood? So whether it is for every chord. Okay. Now, what is the next theorem? Theorem 10.6. What is theorem 10.6? So, sixth theorem. What is sixth theorem? Very good. Adil. Very good. Equal chords are equidistant from the center. So that means, suppose let us say I have a chord of 5 centimeters, for example, and let me draw another chord of 5 centimeters. Let me take a center. Now, how will you draw the distance? By drawing a perpendicular line, right? So draw a perpendicular line to it. Okay, and here also you draw a perpendicular line. So what does this theorem says? Equal chords are equidistant from the center. That means, let us say if it is O and N and O and N, let us say this is AB and this is PQ. So what does this theorem say? If AB is equal to PQ, then They are equidistant. What is equidistant? OM is equal to ON. Very good, priest. So then OM is equal to ON. I don't feel good here calling you beast. Tell me your name. Okay. So after this, the most important theorem which we see, and problems also comes. Okay, so many problems are based on that. Is the angle? See, listen everyone. If you have a chord and this is the center, so how will you tell that the angle is subtended at the center? By joining the endpoints to the center. When you join endpoints of the chord to the center, this we call it as angle subtended at the center. So the angle subtended at the center is double the angle subtended at any other part of the circle. That means, let us say I have a point over here. Let us subtend this angle. If this is x, the angle subtended at the center will be 2x. Okay? And if I take any point on the circle, any point. So since the angle subtended at the center is 2x, the angle will be x. Understood? In the same way, you take anywhere. Okay? On the remaining part of the circle. See, this is very important. If I have taken AB minor arc and I have subtended, or if I have taken AB chord, so and now I have subtended, so it is remaining part of the circle. That means this one. Okay, this is very important. So the angle subtended at the remaining part of the circle will be the angle subtended at the remaining part will be half of the angle subtended at the center. Understood? Don't think that, sir, if it subtends over here, okay, will it be x? No, I am talking about the remaining part of the circle. I am talking only about remaining part. So if you have any doubt, you please, yeah, very good, Adil. It is only remaining part, not this part. Understood or not? So this part you will continue. You will come to know in the next theorem. What is the? Yeah, understood. So this everybody understood. This is a very important theorem, and problems based on this theorem will come in on 9th as well as 10th also. It's very important. Okay. Now the next theorem is, I don't have place, so I am writing over here. So from this theorem, shall I rub this theorem? You understood, right? If I rub if I rub this, if I erase this, now what did you understand? What did you understand? See that the angles are same. Where are those angles? Angles on this is segment, right? Angles in the segment. Angles in the segment are same segment are equal. So the next one is angles in same segment are equal. Got it, my dear students? Angles in the same segment are equal. Very important. This is also very important. And the next one, cyclic quadrilateral. So, okay. Now, okay. The next one, the next theorem is the important theorem, cyclic quadrilateral. What is cyclic quadrilateral? What is cyclic quadrilateral? So if any quadrilateral, if a circle circumscribes a quadrilateral, so what is the meaning of circumscribe? So that means let us draw any quadrilateral. Is this a quadrilateral? Is the circle passing through all the four vertices of the quadrilateral? So this quadrilateral is called as cyclic quadrilateral. This is called as cyclic quadrilateral. Okay. So what is the special feature or character of the cyclic quadrilateral? Can anybody? Good, Ashwet. Very good. No, not opposite sides, honey. It is not opposite sides. Opposite angles are supplementary. Opposite angles are supplementary. That means angle A plus angle C is equal to what? 180 degrees. And in the same way, angle A plus angle B is equal to 180 degrees. In the same way, not B, C. Angle A plus angle C is equal to 180. In the same way, angle P plus angle D is equal to 180 degrees. Okay, so these are the theorems which are very important in circles. What is the first one? Equal chord subtends equal angles at the center. And the second one is, if you draw any perpendicular line onto the chord from the center, it bisects the chord. Okay, and what is the next theorem which is very important? Equal chords are equidistant from the center. There are two chords, and if they are equal, so then the distance between the chords from the center is also equal. And what is the next most important thing? If you subtend any angle at the center, this angle will be double the angle subtended at any other remaining part of the circle. Understood? So from this we can state that angles in the same segment. Suppose if you draw any chord, so anywhere. Okay, they are same. And one more thing we missed here. One very important this thing. Suppose if you have a circle and this is center. If you draw a diameter, okay, so if you draw a diameter, what is this part called as? What is this part called as? The diameter divides the circle into two what? Can anybody? The diameter divides a circle into very good two semicircles. Very good. So now the angles formed in a semicircle by the diameter. Okay, the angles. Listen. Please, no need to press reactions, my dear friends. Wait, Baba. I'm not here to take your impressions or reactions. Wait, please. Listen. The angles formed in a semicircle by the angle subtended at any other point on a semicircle by the diameter is always 90 degrees. So it will be 90 degrees. This is also. It is about semicircle, my dear students. Okay, it is about only semicircle. Don't think this is also 90 degrees. No, it will be only for semicircle. If he gives a line passing through center, then only it is 90 degrees. Otherwise, it is not. Please don't confuse with this and this. What does this tell? That if you have a circle and if you have a chord, then the angles in the same segment are equal. So this is what it says. Okay, it doesn't tell about a semicircle, but here 90 degrees is for semicircle. Okay, got it? Everybody understood the theorems? Now you can tell me whether you understood the theorems or shall I explain any theorem? If you understood all the theorems, then I'll go for the problems. The worksheet problems which I have given. Yeah. Okay. Good. Shall I go for the worksheet problems? Uh, Please practice. See, only listening will not help you, because tomorrow in the examination, the questions are based on the concepts. Okay. Please read. Give me 1 minute. Ha. Please read the question and try to answer. Okay, whoever is the mathematics teacher, whether anyone, whether Deepa ma'am comes or me or any other teacher, if comes, you can clarify the question and clarify the question if you have any doubt, and then answer. Try to answer all the questions. So please don't leave any question. Okay, think what your teachers have taught. Okay, what your teachers have taught during this, you try to think, recollect, and write. Don't leave any question, my dear students. So, I'm going to rub it. Sorry if I'm bothering you. Now, the first question is, if a circle is divided into 10 equal parts, how will you divide a circle? Yeah, this is a circle. Will you divide into 10 equal parts like this? Can you divide circle like this? Equal parts. Can you divide? No. Yes, good, Dawal. You cannot divide a circle like this because it will not be equal. So how will you divide? So you will divide the circle because it is circle, right? Now the circle division means C. This is equal. Okay, and you have here one more four parts. Understood? So, so let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us say they are equal. Okay. So, how will you? Okay, if a circle is divided into 10 equal parts, the angle subtended by each arc at the center. So, this is an arc, each arc. And what is the angle at the center? It is asking. So what we are supposed to do? Here, what is the total angle at the center? Total angle is 360 degrees. And how many parts we have divided? 10. So therefore it is 36 degrees. Understood? My dear friends, please, I'm telling you for God's sake, whenever any question comes in quadrilaterals and triangles and lines and angles, circles, wherever you are, whichever chapter you are doing, whichever grade you are doing from now onwards, try to make a pictorial representation. It helps you a lot in answering the question. So now, second question. In a circle, a triangle has one vertex with an angle of 120 degrees. A triangle has one vertex with an angle of 120 degrees. In a circle, okay. Let us say in a circle, the angle is what? It is 120 degrees, it seems. Okay, a triangle, right? Yes. It is 120 degrees. What is the angle subtended by its opposite side at the center? So let us say this is opposite side, and we have a center over here. So what will be this angle, my dear students? Can anybody tell me? Yes, see, the diagram may be wrong, but according to the concept, the angle subtended at the center will be double the angle subtended at any point. So it will be 240 degrees. 240 degrees, right? According to it. Now, what is the next question? The perpendicular drawn from the center of a circle to the chord, the perpendicular drawn from the center of a circle to a chord, what happens? It bisects the chord, right? It bisects the chord. So it is which theorem? Third theorem, I believe. Third theorem. So the fourth question, if two chords of a circle are equal in length, then the options are they subtend equal angles at the center, they are parallel to each other, they are perpendicular to the radius, they divide the circle into two parts. Very good. Okay, when they subtend equal angle at the center. That's good. The angle subtended by a semicircle at any point on the circle is always the angle subtended in a semicircle. Yes, 90 degrees. Good. Next. Sixth question. If two arcs of a circle are congruent, if two arcs of a circle, acha, okay, arc, okay. So what does this mean? See, two arcs. What is the congruency? Congruency of two arcs. That means they are equal in length. If we find out this to be 5 centimeters and this also to be 5 centimeters, then their corresponding chords. So what do you say about the chords? The chords also will be equal. If it is in the same circle, if it is a different circle with a different radii, then it will not be, they will not be congruent. Okay. If it is in the same circle and arcs are congruent, then chords are also congruent. In a cyclic quadrilateral, the sum of opposite angles is always, in a cyclic quadrilateral, the sum of angles, very good, 180 degrees. Eighth question. Prove that equal chords of a circle subtends equal angles at the center. Equal chords of a circle. Yeah, very good. Frozen warrior. 9.1. Very good. 9.1 theorem. So anybody have doubt in that? Shall I explain or can I skip? Anybody have doubt? 9.1 theorem. Everybody know? Good. Okay. I got one answer. Ashrit. Okay, fine. See, very simple, beta. What did I tell you? What is given? Equal chords. So let us take two equal chords, AB, and another equal chord. Let us take it as PQ. So given AB is equal to PQ, right? So to prove, what to prove? So the angle subtended at the center. So center is O. So what is the angle subtended at the center by AB? AOB. Angle AOB equals, what is the angle subtended by PQ at the center? What is the angle subtended by PQ at the center? POQ. So angle AOB is equal to angle QOB. This we have to prove. Now, what are you having here? Two triangles. So proof. In triangle AOB and triangle POQ, what are equal, my dear students? What is OA? Ashrat, Ashrit, what is OA? Ashrit, what is OA? I want Ashrit to answer. Am I audible, my dear students? Yeah, Ashrat, radius, very good. OA is radius. What is OB? What is OB? OB is also radius. What is OP? In the same way, radius. OQ is also radius. Then here AO is equal to PO. Why? Radius. Then BO is equal to QO. That is also radius. So we have these two. Okay. And after that, what are the equal parts? AB is equal to PQ. AB is equal to PQ. This is given. So when three sides of one triangle are equal to three sides of another triangle, what are the two triangles called as? Those two triangles are called as congruent triangles. By SSS congruency, these two triangles are congruent. So when these two are congruent by CPCT, are these angles congruent? This is how we prove that if equal chords subtend equal angles at the center. Let us go to the next question. Prove that the angle subtended at the center is double the angle subtended at any other point on the remaining part of the circle. Everybody know this theorem, or shall I skip and go to the conceptual questions? It is theorem we have already studied. Good. So, 10th question. A chord of a circle is equal to the radius of the circle. A chord of a circle. I will take class for surface areas and volumes also. So because yesterday I got messages that I knew we need class for circles. I'll explain it in the evening. Let me go home. And if everything permits, I'll take it 4 or 4:30. Okay, once I go home, I'll message you. So a chord of a circle is equal to radius of the circle. Yeah, for this, that is what I tell you. If you read this question, you will not understand what you have to prove. Okay. So let us take a circle. A chord of a circle. Let us draw a chord. Let it be AB. E is equal to the radius of the circle. Yeah, radius means what? If you, okay, that means these two are equal. So given OA is equal to AB. Understood? Find the angle subtended by the chord at the point on the minor arc and at a point on the major arc. Very good. So if I join this, what are these three? This is also radius, this is also radius, and this is chord. And given that chord is equal to radius. So when all the three sides are equal, what is that triangle called as? Very good, Frozen Warrior. It is equilateral triangle. And what is the angle in equilateral triangle? What is the angle in equilateral triangle? 60. Very good, good. See, students, okay, I got very good. I know you know the answer. Wait. So, see, if you don't draw this diagram, let us say you did not draw the diagram, will you get this concept easily? Will you get this question, matlab 60 degrees easily? No. So that is the reason I asked you to draw a diagram once you read the question. Okay. And if you draw the question and write what is given and what to find, you will get at least half mark or 1 mark based on the question, based on the marks. So that is why I tell you usually, please do not leave anything. Write what is given and what to find. If you write only given, then marks will not be awarded. You have to write what is given also, and try to write something related to what is given and what to find if you don't know how to go. Now, so this is 60 degrees. Now tell me, yeah, we have studied now how it looks. Let us take any point on the, this is major arc, right? So what will be the angle subtended by the chord over here? Frozen warrior, think. So the angle subtended at the center is double the angle subtended at the any other point on the circle, right? So it will be 30 degrees. It will be 30 degrees, right? So now angle AMB is equal to half of angle AOB. What is the that is equal to half of 60. That is equal to 30 degrees. How, what will you write? You will write theorem 9.7 as the reference, right? The angle subtended at the center is double the angle subtended at any other point on the remaining part of the circle. Right, my dear students? Good, good, good. Theorem 9.7. Students, listen. In examination, don't write theorem 9.7. You write the statement. Understood? Keeping in the mind the timing, write the statement also. If you write only theorem 9.7, marks will not be awarded. So please take care. So now it is 30 degrees. In the on the major arc, it is 30 degrees. Fine. Now he is asking minor arc also. Okay, let us take any point. Let us take this point. How will you find minor arc? Can anybody tell me? Very good, Kevin. Now everybody listen. Now everybody listen. See, this is what we have written, AB, and this is center 60 degrees. So this will be 30 degrees. And now I want an angle over here. So don't get confused. You just rub everything. You just erase this thing. Now tell me, what is this quadrilateral? What is this quadrilateral? Cyclic quadrilateral, right? Because all the four vertices are on the circle. So if this is 30 degrees, so what will be this? So angle AMB plus angle AMB is equal to 180 degrees. So AMB is 30. So therefore AMB is equal to 180 minus 30, that is equal to 150 degrees. So this is 150 degrees. Understood? So now wait 1 minute. Don't go for reactions. Okay. See, this when they asked angle on the minor arc, you should know that the point is here, and after that you have to visualize this. Yeah, if I remove the, if I erase all the three lines, it will be a cyclic quadrilateral. This you have to visualize. Understood? No teacher will explain you. Okay, no one. No, every problem, for every problem, the concept should be different. The concept will be different. Sorry, the concept will be different. You have to visualize what they are asking. Got it? Now, What is the next question? NCRT 9.1 question number 1. Okay. Where is 9.1? What is the question? Recall that two circles are congruent if they have same radii. Yeah, what are congruent circles? What are congruent circles, my dear students? No, they don't overlap. Very good, Adil. So they have same radius. So that means two different circles with the same radius. Two different circles with the same radius. No, they don't overlap, my dear Adil. Acha. Okay, you are defining it. If you are defining them, okay, fine, they overlap. Oh, that's good. But here in the question, what is the question? If they have same radii, two congruent triangles have same radii. We know that. Prove that equal chords of congruent circles subtend equal angles at the center. Equal chords of two congruent circles. So let us draw once AB. Let us say it is x centimeters, and here also PQ x centimeters. Subtend equal angles at the center. If the center is M and the center is M. So you have to prove that AMM is equal to PMQ. Is it easy? Is it same as 9.1? Is it same as 9.1? Because AM is equal to PM, MV is equal to PQ. Why? Radius are equal, already told. And it is given that AB is equal to PQ. So this is what I told you. Until and unless you draw the diagram, you will not understand. Okay, first read the question, draw the diagrams. If you represent the given statement in diagrams, I will give you a half mark at least. But without diagram, please don't do it. Yeah, by SSS, Krishwaran, good. By SSS congruency, they are congruent, right? Next question, exercise 9.2, question number 2. 9.2. If two chords of a circle intersect within the circle, prove that the segments of one chord are equal to corresponding segments of other chord. This I will explain you at 4 o'clock. I have two reasons. Okay, the first thing is it's already 2:45. Everybody is going, and the next thing is my the charging of my laptop is very low. So because it takes some time. Next, fourth question. If a line intersects two concentric circles with center O at A, B, C, and D, prove that AB is equal to CD. This is easy. I can explain you within 2 minutes. Okay. If a line intersects two concentric circles, draw two concentric circles. Okay, draw two concentric circles. So that means two circles having two circles with the same center are called as concentric circles. Okay. If two concentric circles with the same center with center O at A, B, C, D. If a line intersect two concentric circles, okay. So that means what? It goes like this. 9. So this is A, this is B, this is C, and this is D. Okay, there are 4 points A, B, C, D. Now, prove that AB is equal to CD. Where is AB? This is AB, and this is CD. If you see this problem like this, you may not do. Okay, but if you see each circle at a time, I'll rub this. Okay, so what is this? A circle, center, and a chord, right? So now, if I draw a perpendicular onto chord, what happens? What happens, my dear students? Yeah, perpendicular. Very good, Sahil. Perpendicular drawn from the center of the circle bisects the chord. That's good. So let us say this is M. So now draw OM perpendicular to BC. Okay, then that implies BM is equal to CM, right? BM is equal to CM. This is first equation. Everybody understood? BM is equal to CM. What will you write the reason? You will write the perpendicular theorem 10.3, right? So theorem 10.3, perpendicular from center bisects the chord. Bisects the chord. Now understood this point? Now you have to visualize the bigger circle. So to explain you, and I will rub this. So now what happens? It is a circle, and AD is the chord, and the OM is perpendicular. So that means what? AM is equal to DM. Is it right? So now, since OM is perpendicular to AD, OM is perpendicular to AD implies what happens? AM is equal to TM. This is second equation. Okay. So now let us go back to the main question. So how will I get AB? How will I get AB? Yeah, from AM, if I subtract BM, will I get AB? Good. So, okay, good. Sahil, you have told that subtract second equation from first equation. Okay, whatever it is, first or second. What is this? Is it a theorem or an axiom or an postulate? Can anybody tell me? Axiom. Can anybody recall that axiom which we have studied in Euclid's geometry? Which we have studied in Euclid's geometry. I know. Can anybody state it? Can anybody state the theorem? Okay, I will. See, we have studied, you will remember this. When equals are added to equals, no. That is, when a ray stands on a line, that is axiom number 1. See, I'll explain you. When we add equals to equals, the sum are equal, right? In the same way, there is one more. When you subtract equals from equals, the difference is equal. So the same concept, this is equal and this is also equal. Which is the bigger one? AM is the bigger one, right? So you have to subtract first from second. Okay, write the second. AM is equal to DM and BM is equal to CM. When I subtract, AM minus BM is equal to DM minus CM. AM minus BM is AM minus BM, what is left out? AB. And from DM, if I subtract CM, what is left out? CD. So this is what he asked us to prove. Understood? Allah. Good. So, then what is the next question? You see, the charging in the phone also is 6%. So, today I forgot actually my charger at home. I'll stop with this because both the chargers charging is not there. I fear that this will not be saved. So, once I go home, after having lunch, I'll message you. Okay? Take care, bye, and repeat the problems. Okay, and last thing, the word problems and what is that section D? Section D, most of the questions and section C also, they are from textbook problems. So please practice textbook problems all. Okay, these are only for sample. So you have to practice all the problems. Okay, Alhamdulillah, you got 5 days of weekend for examination. So I believe this time everybody will get good marks. Okay. Okay, it depends. You pray. Let us see what Allah Ta'ala decides. And inshallah, take care, my dear students. Okay. Bye bye. I'll message you once I go home. Okay. Please practice. Please practice. Walaikum assalam wa rahmatullah.